Hello, my name is Arthur, and today Martin and I will be presenting our final course project in problematic internet use. So the first thing we will look at is the problem. The problem for this project is from Kaggle competition, which was created by the Child Mind Institute. The data for this competition was provided by the Health Brain Network, which is a landmark mental health study based in New York City. It has been taken on about 5,000 children between 5 and 22 years of age. The goal is to find a way to predict problematic internet use by various measurements such as physical activity, physical shape, number of hours that's been spent on the internet per day, and other data. For this, a standardized measurement is used called the Severity Impairment Index, or SII. The data for the problem is split into two parts. First being a CSV file containing a large number of different measurements. These measurements include a number of hours spent on a computer or on the internet per day, the physical composition and how active they are, the results on fitness tests. Additionally, there are some other measurements like sleep disturbance scale. A lot of the entries were missing, but due to the data being linear, we were able to impute a lot of the data and fill in the other missing values with the median or mean based on age group. The second part consisted of measurements from ActiGraph that gave us time series data of activity and rest measurements. For a reason of file size, the data was stored in Parquet files opposed to CSV files. This is because Parquet files have more efficient compression and better query performance. This data accounted for about 1/3 of the subjects, meaning that 2/3 didn't work the ActiGraph for measurements. For both data sets, we did analysis on their own, and later for model training, we merged both together.
After conducting the necessary data cleaning, imputing, and feature selection, we started fitting different models to see which ones would provide the best results. Since there's only 4 values for SII, we decided to test not only regression but also classification algorithms. The best results were achieved by a logistic regression, random forest classifier, and gradient boosting. We were able to achieve at most 62% accuracy for our models. This is not too accurate, but it definitely supports a correlation between features and the target, as random values would give us around 25%. When it comes to regression, the results were not too much better, with reach, gradient boosting, and linear regression achieving R-squared scores of around 0.21. While this value confirms a correlation between features and target, it doesn't meet the standards for a model that explain the correlations well. After applying different regression models, we've decided to see the most important features for a gradient boosting regressor. The most important feature seems to be the amount of sleep disturbance, which seems more like a correlation than a causation. The second most important feature was the number of internet hours, which supports the claim that the number of hours spent on internet can cause problems with internet use. Third and fifth, and some other features that had an impact on the models were physical attributes and capabilities, which would suggest that the amount of time spent on physical activities impact the development of problems with internet use. Fourth feature is not too surprising since age correlates with mental development and therefore also has an impact on developing problems. With all of this project deserves a lot more expertise and time for research and development. Unfortunately, there is a deadline for this project and some things have not been explored during this project, one of them being to further explore features in the dataset. Also, we didn't handle the correlation between physical attributes with age and sex. This has most likely led to skewed results as young children have different body compositions than adults. There was also a little to no exploration of patterns in the time series data, which could have provided valuable insights. And lastly, there could have been some more research put into applications of neural networks, but for the lack of time, this wasn't explored.